Hello and welcome guys to my YouTube channel. In this video, we will be talking about further applications for ratios and more challenging concepts that you might face in harder ratio questions. Now we're going to start with ratio and fractions or percentages. Now in harder ratio questions, you'll be dealing with fractions and percentages. The key to solving those questions is to know how to express a ratio as a fraction. And we've already explained this in the previous video. So, for example, in a library, the ratio of fiction books to non-fiction books is 5:15. So this means that 5/20 of the books in the library are fiction books, and 15/20 of the books in the library are non-fiction books. Now, how did we get those fractions? Well, I firstly added 5 plus 15, and I got 20, which was the total number of parts. And we know that fiction books have 5 parts, so 5/20, okay? And non-fiction books are going to be 15 parts over 20. And these fractions aren't even simplified. You can further simplify, for example, this fraction into 1/4. And this fraction over here into 3/4. Okay? If you still don't understand this concept, I will make a small example over here. So let's say you had a pizza, okay? And you sliced this pizza into 8 pieces. Okay, so now we have 8 slices and we want to divide them among 2 people in the ratio 2:6. So 2:6, this means the first person will receive 2 parts and the second person will receive 6 parts out of an entire 8 parts. So the first person will receive those 2 parts, okay? So if I wanted to express this as a fraction, how much did he receive? He received 2 pieces out of a whole 8 pieces, okay, or slices. Now, as for the other person, he will receive all of the other 6 slices out of a possible 8. Okay, so 6/8 is the fraction of the pizza that the second person received, and 2/8 is the fraction of the pizza that the first person received. And of course, these fractions can also be simplified. Okay, now let's get back to our example over here. So now we know that 5/20 of the books in the library are fiction books and 15/20 are non-fiction. Given that 1/5 of the fiction books are over 200 pages long, okay? So, and also we know that given that 1/3 of the non-fiction books are over 200 pages long, all right? Now, let's say I wanted to know what is the proportion or the fraction of books that are over 200 pages long. Okay? Now, how will we figure this out? Here's how we do it. Firstly, when it comes to fiction books, we have 5/20. So 5/20 of the entire collection of the books are fiction. Now, 1/5 of those 5/20 are over 200 pages long. So how can I find the fraction that represents this scenario? I will multiply by 1/5. And this will give me 1/20, okay? Or 0.05, all right? So what can I tell here? This right here is the proportion of fiction books that are over 200 pages long, okay? And this proportion is of the entire collection of books, okay? This right here, the 1 over 5, it is not 1 over 5 of the entire collection of books. It's only 1 over 5 of the fiction books. 1 over 20 is the fraction of the entire collection of books, okay? Now, as for this over here, 1 over 3 of non-fiction books. Now, I know that 15 over 20 is the fraction of non-fiction books. If I multiply that by 1 over 3, I will get 5 over 20. All right? Which simplifies to 1 over 4. So, 1 over 4 or 0.25 of my books are non-fiction books that are over 200 pages long. Okay? So now, what is the proportion of books that are over 200 pages long? It's going to be 0.05, which is the proportion of fiction books that are over 200 pages long, plus our 0.25, and this gives us 0.3 or 30, it doesn't matter. Okay? So this is how the proportion works. Okay, so now I can tell that 0.3 of my books are over 200 pages long. Okay, and if I wanted, I can turn this into a fraction. It will be 3 over 10, and I can even write it as a percentage by multiplying by 100. We get 30%. Okay, so there's multiple ways we can write this information, either as a decimal, as a fraction, or as a percentage. Okay, so again, 30% of all my books are over 200 pages long. Okay, I need to understand that we never needed to know the number of books to figure out all of this information. Okay, so we only worked with abstract percentages. Okay, and it worked just fine. Okay, let's take a look at this example. A bakery sells only 2 types of cookies, chocolate chip and oatmeal raisin. The cookies come in 2 sizes, small and large. The ratio of chocolate chip cookies to oatmeal raisin cookies in the bakery is 7 to 3. Okay, so this is the ratio between them. So I'm going to go ahead and write this down. 7 and 3. And the 7 is going to be chocolate chip, and the 3 is oatmeal raisin. Okay. Now, 30% of the chocolate chip cookies are small sized, and 2 over 5 of the oatmeal raisin cookies are small sized. What percentage of all the cookies in the bakery are large sized? Okay. So now, what I'm going to do is firstly find the percentage of the small sized cookies, okay? And then I'll find the percentage of the large sized, okay? So let's start by writing down the fraction of the chocolate chip. Now the chocolate chip have 7 parts out of a total of 7 plus 3, 10 parts, okay? So this is the chocolate chip. And I will do the same thing with the oatmeal raisin, which is 3 parts out of a possible whole 10 parts, okay? Now, what do I know? 30% of chocolate chip are small sized. So my chocolate chip already represented by 7 over 10 as a fraction. 30% of them, so I'll multiply this by 30%, are small sized, okay? So you can go ahead and plug this on the calculator and gives us 21 over 100. Okay. Now I'm gonna write it over here. As for the oatmeal raisin, we know that they represent 3 over 10 of the cookies, and 2 over 5 of them are small size. So I'll multiply this by 2 over 5, okay? And you can go ahead and plug this on the calculator to get a fully simplified fraction, which gives us 3 over 25, okay? So now I can add those two numbers, okay, those two fractions, and when you add them, you get 33 over 100, okay? So again, what is this 33 over 100? This is the proportion or the fraction of small-sized cookies. All right, whether they're chocolate chip or oatmeal raisin, overall, this is the proportion of the small-sized cookies. All right, now, are being asked what is the percentage of all the cookies that are large-sized, okay? So now, in order to find, so here's the thing. So if we know that 33 over 100 are basically the small-sized cookies, okay? So how can I find the large-sized? The math behind this is to simply know that we have basically 100 parts and 33. So we can just subtract 1 minus 33 over 100, okay? Because what this will be basically, you will just make a common denominator over here, and you'll be subtracting 100 over 100 minus 33 over 100, okay? So you're finding the complete opposite. This gives you 67 over 100. So 67 over 100 is the proportion of the large-sized cookies. So now the question is asking for a percentage. I can just write this as a percentage. So 67 over 100 is just simply 67%. Okay, so this is the percentage of the large-sized cookies. I hope this was clear. You know, the second thing that you might face is how to combine ratios. Now we need to understand that two separate ratios can be combined together if they have a common variable that links them, okay? So let's take a look here. On a ranch, there are 351 animals. The ratio of horses to goats is 4 and 5. I would write this. So horses to goats, it's 4 to 5. The ratio of goats to chickens is 8 to 9. So ratio of goat to chicken is 8 and 9. So now we're being asked to find the number of chickens, goats, horses in the farm, okay? Now, it's really important to understand that when you have two separate ratios, none of them can be used separately with the 351 animals, okay? You need to combine them first. This is the only way. Now, how do I combine them? Well, our common link right now is the goat, okay? That's the common link between those two ratios. But in order for me to be able to just link them together, I need to have the parts equal over here, so the same number, okay? So what we're looking for is the lowest common multiple of 5 and 8. which is 40. Okay. So now we've learned from the previous video that we can scale up our ratios by simply multiplying everything. So I'll multiply everything here by 8. And I will multiply everything over here by 4. Now on this side, we're going to get 32 and 40. And on this side, we're going to get, I shouldn't have multiplied by 4. I meant to say 5. We get 40 and 45. All right. So now I actually have the same number of parts for the goats. So I can finally combine this ratio for everybody. So horses to goats to chickens, it will be 32 horses to 40 goats to 45 chickens. Okay, so now that I've made the parts of the goats equal on both ratios, I can just combine them. Okay, now I have this combined ratio, and this combined ratio is what will solve all of my problems now. Okay, so now in order to find the number of chicken, goats, and horses, I will firstly obviously find the total number of parts by adding my parts. I'm going to plug this in the calculator, and you get 117. And now I want to find what each part represents, so I will divide the total animals by 117. And we get 3. Okay, so every part represents 3 animals. So now let's find the total number of horses is 32 multiplied by 3, which gives us 96. The total number of goats is 40 multiplied by 3, which gives us 120. And finally, the total number of chickens is going to be 45 multiplied by 3, which gives us 135. Okay, so I hope this was clear. Also, the answer is right here. Now, the final concept that we need to understand when it comes to ratios is what happens when ratios change. Let's take a look at this clarifying example. Now, a jar contains 28 candies consisting of only strawberry and blueberry candies, with the ratio of strawberry to blueberry candies being 4 to 3. So I will write this information. So we have strawberry and blueberry, and the ratio is 4 to 3. Now, Alex adds some blueberry candies to the jar so that the ratio of strawberry to blueberries candies becomes 2 to 5. Okay, so what happened is that we added blueberries, okay? And now our ratio of strawberries to blueberries is 2 to 5, okay? Now what I want to know is how much blueberry candies did I add? All right. Now, the way we figure this out is as follows. You need to firstly find all the information you can before we added and then after we added. Okay? So firstly, before we added, I know that I have a total of 28 28 candies. By the way, I don't know why I wrote this sentence over here. Hold on, let's just delete this. I mean, the question right here is saying determine how many blueberry candies Alex added to the jar. But for some reason, I didn't read this. I thought it wasn't there, so. All right, so let's continue here. So again, we want to figure out as much information as possible from before. Now, I can easily figure out that the amount of strawberry candies that I had and the amount of blueberry candies that I had. We do this by finding how much each part represents. Firstly, I'm going to add the parts. So 4 plus 3 is equal to 7. And then I will divide 28 by 7. This is the parts, okay? And 28 by 7 gives us 4. This is the candy per part, okay? So now for strawberries, we have 4 times 4 because we have 4 parts, each represented by 4 candy. So 16 pieces. And as for the blueberries, we have 3 times 4, and it gives us 12 pieces. Okay, so I hope this was clear. Now, how will we figure out how much blueberry was added in the next scenario where the ratio changed? The most important thing to understand here, and what will actually solve the question for you, is this little trick where you should remember that the strawberries never changed. Okay, so I know that I only added blueberry candies, which means in this ratio right here, the number of strawberries is equal to 16. It never changed. And this right here is the clue that will solve the question for you, okay? So this is why it's important to figure out what variable didn't change, find the amount of the pieces for that variable, and take it to the next ratio right here. So now I have a ratio question, okay, where I actually know that the strawberries are 16 pieces. I can use this to figure out how many parts does each piece represent in this ratio. Because how many parts, because how many candies does each part here represent differs from how many candies does each part represent over here. So how will I figure this out? I will divide 16 by the parts for the strawberries, which are 2. And we get 8. Okay, so this is 8 candy per part. Okay, so as you can see, in this ratio over here, each part represents 8. But in this one, each part represented 4. Okay, this happened because I added blueberries. All right, so can I now figure out how many blueberries I have? Yes, I can just multiply 5 parts of blueberries multiplied by 8 per part, and we get 40 pieces. Okay, so after adding blueberries, I have 40 pieces. Now you should note this isn't the final answer. This is the amount of pieces I have of blueberries in this ratio. Now, the question is asking how many did I add? How many did Alex add to the jar? The way to figure this out is, okay, so I know that I have 40 pieces now, and I previously had 12 pieces, so I will subtract 12, okay? And we get 28. All right, so this is the amount of, so Alex added 28 pieces of blueberries, okay? Now let's take a look at examples that will cover all of the previous concepts we've explained. There are some blue counters and some green counters in a box in the ratio 2 to 7. There are 28 green counters in the box. Work out the total number of counters in the box. Okay, so as for part A, I will go ahead and write my ratio. And this is blue, and this is green. And I know that I have 28 green counters, okay? I can use this 28 to actually find what each part of this ratio represents. I will divide 28 of the green counters by 7 parts for the green. And this gives us 4. So 4 counters per part. Now I can find how many blue counters I have by multiplying 2 parts for blue by 4 counter per part, and we get 8 counters. So what is the total counters? The total counters is 8 plus 28. This is the blue, and this is the green, and we get 36 in total. Okay? Moving on to part B. Alice puts some more blue counters into the bag. The ratio of blue to green is now 1 to 2. Okay. How many blue counters did Alice add? Okay. So if I want to sum my information firstly, I firstly had a ratio of 2 to 7, a blue to green counters, and I had 8 blue counters and 28 green counters. Okay. Now I know that Alice added blue counters, and the new ratio is 1 to 2. So now the blue and the green are now represented by the ratio 1 to 2. And now I'm being asked how many blue counters did Alice add? Well, I want to figure out the new amount of blue counters. So again, we care about finding the constant, the thing that didn't change. We added blue, which means my green counters are exactly the same, which means in this ratio, we actually have 28 green counters. So I can divide the 28 by 2, and I get 14. Okay, so 14 counters per part. So this ratio is actually represented by 14 counters per part. So now I can find the number of blue counters by multiplying one share by 14, which will just give you 14 counters. Okay, so those are the blue counters in the new ratio after Alice added the blue counters. Okay, now the question is asking how many did she add? Well, we had 8 blue counters and now there are 14. So 14 minus 8, which gives us 6 blue counters were added. Okay, so I hope this was clear. Okay, let's take a look at the second example. There are some blue counters and some green counters in a box. There are 42 green counters in the box as well. Okay. The ratio of the number of blue counters to the number of green counters is 2 to 7. Work out the number of blue counters in the box. Okay. So let's write down my ratio. So we have blue counters and green counters, and the ratio between them is 2 to 7. And we know that there are 42 green counters. And I want to figure out the number of blue counters in the box. So I will go ahead and divide the 42 green counters by the parts for the green, which are 7. Okay, 42 divided by 7 will give you 6. So now I know this is basically the counters per part. I will multiply it by 2 to find the number of blue counters, and we're gonna get 12 blue counters. Okay, so this is the final answer for part A. We'll go ahead and solve part B over here. Sam adds some more blue counters into the box. Okay, so I know that I'm adding blue. The ratio of the blue counters to the number of green counters is now 3 to 7. So now the ratio of blue to green changed to 3 and 7. How many blue counters does Sam add to the box? All right, so now we know that he added blue, which means the green never changed. The previous green was 42, and it stayed that way. So I will go ahead and write 42 green counters over here because this is what I have. And I will use it to figure out the parts of this ratio by dividing 42 divided by 7, and this gives us 6. So now I can go ahead and multiply 6 by 3. We get 18 counters. So now we know that there are 18 blue counters. So how much did Sam add to the box? I will subtract 18 minus the previous blue, which was 12, and we get 6. So he added 6 counters to the box. 6 blue counters. Okay, let's take a look at this word problem. In a box of markers, there are 4 times as many black markers as yellow, and 3 times as many yellow markers as purple markers. For the markers in the box, write down the ratio of the number of black markers to the number of yellow markers to the number of purple markers. So we want to write down the three-way ratio, okay? Now, what we need to do over here is express those sentences as ratios, okay? So we have a ratio here between the black markers and the yellow. And what it says is that 4 times as many black as yellow. So for every 1 yellow I have, I will have 4 black. So the ratio will be 4 to 1. Okay, and I'm going to go ahead and write this down over here. As for the second sentence, 3 times as many yellow as purple. So the ratio is between yellow and purple. And we can see that there's 3 times as many yellow. So for every 1 purple, we have 3 yellow, okay? So 3 and 1, and I will go ahead and also write this down over here. And the question is asking us to write the ratio of black to yellow and to purple. So in order to combine these two ratios, I will go ahead and look for the shared element, which is the yellow. I need to make the yellow parts the same in both of these equations. In both of these ratios. This is relatively easy because you have a 1 for the yellow here. So you can just go ahead and multiply only this side by 3. It will become 12 and 3. So now I have the common part. So now the final ratio will be black as 12 and yellow as 3 and purple as 1. This is the final answer. Alex, Ben, and Chloe share some money. Alex gets 4/12 of the money. Ben and Chloe share the rest of the money in the ratio 4:3. What is Chloe's share of the money as a fraction? Okay, so this is quite an interesting question. So we know that you have Alex, and you have Ben, and you have Chloe, and they're sharing money, and Alex got 4/12 of the total money. Okay. Now we know that Ben and Chloe share the rest of the money. So the question is, what's the portion that Ben and Chloe share? Well, if Alex got 4/12, then I can find Ben and Chloe's share by subtracting 1 minus 4/12. Okay, because the 1 is basically the whole. Okay, the 1 is 12/12, really, the whole part. So now if you subtract this, you get 8/12. Okay. You can think of it as if you have 12 parts. 8. Those are 8, and now they're 10, and now they're 12. Okay. So you can think of it as Alex taking 4. So now the remainder is 8 for Ben and Chloe. Okay, so 8/12. Now we can simplify this fraction, and it becomes 2/3. So the fraction of money that Ben and Chloe are sharing is 2/3. Okay, so this is 2/3 to share. Now both of them are sharing it in the ratio 4:3. So this is between Ben and Chloe, 4:3. So we're being asked, what is Chloe's share? Well, Chloe's share of this ratio will be 3 parts over the total number of parts, which is 7. Okay, so based on this ratio, we will be dividing my money, the portion of the money, which is 2/3, for Ben and Chloe, and Chloe will take 3/7 of it. So Chloe's money share of the original amount of money will be 2/3, which is what was left for Ben and Chloe, multiplied by 3/7, which is Chloe's share, and this gives us 2/7. So overall, Chloe got 2/7 of the money. So again, you didn't have any, we don't know the amount of money really, but you don't need it to figure all this information out. All right. A jar contains only yellow, purple, and orange marbles. The ratio of yellow marbles to purple marbles is 7 and 11. So yellow, purple, 7, 11. The ratio of purple to orange is 2 and 5. And now we're being asked to calculate the percentage of marbles that are purple. All right. You can't figure this out again without combining the ratios first. Okay, this is always the first step, whether you're dividing money or dividing anything or trying to find fractions or percentages, you first need to combine your ratios. Now, if we take a look at those ratios, we have a common link between them, which is the purple. We need to look for the lowest common multiple between 11 and 2, which is 22. So I'll multiply this by 2 and multiply this by 11. This will give us 14 and 22, and this will give us 22 and 55. So now if I go ahead and combine those three-way ratios, I will get 14 22, and 55. Now, to find the percentage of marbles that are purple, I will divide the 22 parts by the total number of parts. Let's firstly find the total number of parts. I'm gonna go ahead and plug those numbers on the calculator. Get 91. So 22 over 91. Okay. This is the diffraction of the marbles that are purple. Now, in order to give it as a percentage, I will multiply it by 100, and we should get 24.2%. Of course, this is rounded to 3 significant figures. Okay, let's take a look at the final example. Oh, there's actually one more. Okay. In a book club, the ratio of the number of boys to the number of girls is 4 to 3. 30% of the boys are under the age of 18, and 15% of the girls are under the age of 18. What percentage of all the people in the book club are under the age of 18? We should give your answer to 1 decimal place. Okay, so firstly, let's write my ratio. So boys to girls, the ratio is 4 to 3, okay? And now let's figure out the fraction of boys. The fraction of boys is going to be 4 over 7, the parts over the total, and the fraction of girls is 3 over 7, okay? So now you need to understand that 4 over 7 and 3 over 7 are of the whole entire club. You have 4 over 7, the fraction for girls, and 4 over 7, the fraction for boys, and 3 over 7, the fraction for girls. Now, we know that 30% of this 4 over 7 is under the age of 18. So how many boys are under the age of 18? I will multiply 4 over 7 multiplied by 30%. And you can go ahead and plug this on the calculator, and we get 6 over 35. Okay? All right. So now, as for the girls, we have 3 over 7 multiplied by 15%. And again, I will go ahead and plug this on the calculator. We get 9 over 140. Okay, so this is the proportion of the entire club of girls that are under the age of 18, and this is for the boys. So what is the percentage of all the people that are under the age of 18? I will add both of my fractions firstly. So adding this on the calculator gives us 33 over 140. And in order to find it as a percentage, I will take it up over here. I will multiply by 100. And our final answer, rounded to 1 decimal place, will be 23.6%. Okay, so I hope this was clear. All right. In a town, the ratio of adults to children is 3 to 2. 30% of the adults own a bicycle, and 2/3 of the children own a bicycle. What is the proportion of people who own a bicycle in the town? Give your answer as a simplified fraction. Okay, so adults to children, we have the ratio 3 to 2. So for adults, we have 3/5 as a fraction, and for children, it's 2/5. Now, 30% of the adults own a bicycle, so I will go ahead and multiply 3/5 multiplied by 30%, and I will go ahead and plug this on the calculator. We get 9/50. Okay. Now, as for the children, 2/5, this is the proportion of children, multiplied by 2/3, which is the fraction of the children that has a bicycle. And there's no need to plug this. You can just write the answers, 4/15. Okay, so now the question is asking what is the proportion who own a bicycle. I will add those two because this right here, this is the adults with a bicycle. And this right here is the children with a bicycle as well. So plugging this on the calculator gives us 13/15, and this is the proportion. This is the fully simplified fraction. Okay, now let's move on to some exercises. You should pause the video and try to solve each of them and then check your answer. A jar of candies contains only chocolates, gummies, and lollipops. The ratio of the number of chocolates to gummies is 4:5. Okay, so chocolate to gummies is 4:5, and the ratio of the number of gummies to lollipops is 6:7. So gummies to lollipops is 6:7. What fraction of the candies are gummies? Okay, before we answer this question, we must combine our ratios. The common link is the gummies right here. I will go ahead and find the lowest common multiple between 6 and 5, which is 30. So multiply here by 6, multiply over here by 5. This gives us 24 and 30. And over here we get 30 and 35. Now I can go ahead and write a ratio between chocolate, gummies, and lollipops, which will be 24, 30, and 35. So now I can go ahead and find the fraction of the candies that are gummies. The gummies are 30 parts over the total number of parts, which is 24 plus 30 plus 35, and we get 89. So 30 over 89. Now we can plug this on the calculator to get a fully simplified fraction. There is a simplification, but there isn't any simplification. This is the final fraction. Okay. Moving on to question 2. In a zoo, the number of lions and the number of tigers are in the ratio 5:4. So tigers and lions, and the ratio is 5:4. The number of tigers and the number of bears are in the ratio 3:2. So tigers and bears, we have the ratio 3 and 2. The total number of lions, tigers, and bears is 210. Okay, so this is the total. How many tigers are in the zoo? Now, it would be so wrong to try to figure out the tigers from this ratio alone or this ratio alone, okay? Because this ratio alone does not represent the total. The total should be a ratio between lions, tigers, and bears. So as usual, you need to combine the ratios. The link is the T right here, the tigers, okay? So how will I make the same parts for the tigers? I will multiply this by 3 and multiply this over here by 4. On the left, we're going to get 15 and 12. And over here, we're going to get 12 and 8. So my three-way ratio will be 15, 12 parts tigers, and finally 8 parts bears. Now, how many tigers are in the zoo? There's 12 parts, but I need to figure out how much does one part represent. By dividing 210 over the total parts, I will add 15 plus 12 plus 8, 20, 35. So I will write 35 over here, and I will plug this on the calculator, and we get 6. So basically, this is 6 animals per part, okay? Now the tigers have 12 parts, so 12 multiplied by 6, and this gives us 72 tigers. Okay, so this is the final answer. Moving on to exercise 3. Again, pause the video and try to do it on your own. The ratio of the number of apples to oranges in a basket is 4 to 3. So we have apples, we have oranges, the ratio is 4 to 3. There are 12 oranges in the basket. So we know the number of oranges, it's 12. After adding more apples to the basket, the ratio of apples to oranges becomes 2 to 1. Okay, so we added apples, and the new ratio of apples to oranges is 2 to 1. Now we're being asked how many apples were originally in the basket. Okay. Oh, this question is not supposed to be phrased like this. No. We don't want to know. Hold on. We want to know how many apples are in the basket after. Okay, so how many apples are in the basket after adding? Okay, so this is what we want to know. Now, if we take a look over here, we know that the previous number of oranges was 12, and I only added apples, which means over here I will still have 12 oranges. The number of oranges never changed. So now I want to figure out how much does each part represent by dividing 12 by 1, because 1 part orange, which just gives you 12. So each part represents 12. So now the amount of apples will be 2 times 12. This gives us 24 apples. Okay, so this is the amount of apples after I added. Let's take a look at the final question. Diana, Emily, and Frank share some money. And Diana gets 5 over 15 of the money. And Emily and Frank share the rest of the money in the ratio 5 to 4. What fraction of the money did Frank get? So now you have Diana, you have Emily, and you have Frank. And they're sharing the total, by the way, the total number of their sharing, like total parts, is 15, okay? In any case, we know that Diana got 5 over 15. So this leaves Emily and Frank to share 15 over 15 minus 5 over 15, which is 10 over 15, okay? So this is the amount that Emily and Frank will share, and they are sharing it in this ratio. So Emily to Frank, they're sharing it 5 to 4. So we're being asked what fraction of the money did Frank get? Well, Frank has 4 parts out of a total of 9, and he is sharing 10 over 15 of the money, of the original amount of money. So we'll plug all these numbers on the calculator. We get 8 over 27. This is the fraction of money that Frank got, the fraction from the original amount of money that Frank got. Okay, I hope this was clear, and thank you for watching.